Let me adjust one more thing here because it wants to record. All right, I don't even care. Okay. We'll talk about complex numbers some more in a minute. Let's do a quick cubic number thing. I don't remember what we did in this class yesterday. Let's go with that one. With those same numbers? Oh, okay, let's try 125 back here. And I'll get really funky. How's that? Since you're... Okay, that one's just mean. Cube root everything for the first parenthesis. So the cube root of this is, anybody remember? 4 and an x. Good job. And back here, the cube root of this, 5 and an n. Okay. The rule is you keep the same sign there. And then, does anybody remember how the next parenthesis goes? Square that one. 4x times 4x is... Good job. At the back, we square that one. 5n times 5n would be a lovely... Okay. In the middle, you get one of each. So we multiply this times this and put it in the middle. 20nx or something? 20xn, whichever. I don't care. Okay, that's... Can you see that at all? That's a blob. Not much better. Okay. And then the signs. This one stayed the same. This is the opposite. And this guy's always positive. Okay. There's an example. Is it helping to see one every day for those? All right. And then the other thing I wanted to do one of today. I'll make something up that won't come out nice because I'm making it up. Okay. We're going to do the equation of a line through 2 points. All right. How do we start that always? Slope. Okay. And slope, remember, is subtracting y over x. Got a few people still doing that upside down. So we have x, y, x, y. This is 0.1 and this is 0.2. So the y's would be 5 and 7. The x's would be -2 and 3. And this is subtracting, remember? I get -2 over -5, or a +2/5. Way to go, Hofbauer, with an ugly slope. Okay. Now, if I want an equation of a line, my suggestion is you get used to using this slope and one of these points. I'm going to pick this one because it has 2 positive numbers. Is that okay? So I'm going to, the form is, whoa, just kidding. There we go. So I'm going to put this 7 in for y1, my slope of 2/5 in, and then x minus the x1, which would be x minus 3. Then you distribute. And again, I didn't make this very nice. It would be 2/5 times x. This is a 3 over 1. You could use your calculator. 2 divided by 5 times 3. But it comes out 6/5. Now, it depended what form I wanted you to do, okay? If it said slope intercept, you would solve for the y. And you'd get y equals 2/5 x. Anybody have a calculator out? -6 divided by 5 plus 7, math, enter, enter, 29/5 maybe? Okay. Again, that was -6 divided by 5 plus 7, and then a math, enter, enter to get that. Okay, can we just stop and we'll do, or do you want to see a standard form of that? Let's just be done with that for today, okay? All right, on to imaginary numbers. The target today is to be able to add, subtract, and multiply complex numbers. That means numbers with an I in there. and then rationalize when they have an I in the denominator using what's called a conjugate. We'll get there. And simplify powers of I. Okay, we're going to review some exponent powers, but I'll wait till we get there. What is I and why do we use it? That's a little off your screen, I think. Sorry. When you have the set of numbers, you have whole numbers, which are part of integers, which are part of rational numbers. You have irrational numbers. Anybody know what irrational numbers are? Actually, if it can be written as a terminating decimal or a fraction, it is a rational number, okay? Rational is anything that can be written as a fraction, so decimals and fractions generally are rational. Irrational decimals would be like pi, e, things that don't end. And then crazy irrational numbers like the square root of 3. Did you ever notice all those square roots that aren't simplifiable? They're all crazy decimals, okay? I always call this a crazy jail, okay? This is, everything in here is a crazy jail. Sometimes somebody gets out because they're a nice perfect square, but when they stay in here, it's the irrational ones. Okay. Then, look. Then over here we have complex numbers, and I found this nice graphic. It says, when you have real numbers that are combined with pure imaginary numbers are things that only have an I part, then you get what's called a complex number. A complex number is like here, A plus BI, where you're adding and subtracting. And so I'm not going to quiz you on this vocabulary, but I'm introducing you to the idea that a complex number could be like 2 plus 3i. It could have an imaginary part and a real part added or subtracted. All right, let's go back and talk about what I is. I, by definition, is the square root of -1. We're doing this because we're going to come up with quadratic formula next. Do you remember quadratic formula with that big old radical had underneath it a b squared minus 4ac? Is that sounding a little familiar? That's tomorrow's lesson, okay? And when we do that, sometimes we get a negative inside the parenthesis, or inside the radical, sorry. So the square root of a negative number is not real. We can't do it in the real number system. But the square root of -1 is defined as I. All right, in our Google Classroom, I guess I didn't put it in here. In our Google Classroom, today's materials post has a video about where in the real world we use imaginary numbers, if anybody wants to watch it. It's like 16 minutes long. If anybody really cares about why we ever learn this, okay? I know they do use it in electrical engineering and stuff to indicate current. They use imaginary numbers, something like that. I'm probably pulling that out of you know what. But anyway, so quick example, if we had the square root of -25, that could become the square root of -1 times the square root of 25. And the square root of 25 is 5. And the square root of -1 we would substitute as an I. Okay? So when you see something like, we'll say the square root of -48, that would be the square root of -1. Now 48 is actually 16 times 3. Anybody know what that would look like when we finish simplifying? Nice. Square root of 16 is 4. The square root of -1 is I, and somehow they always write that like a variable after the constant. And then this guy's got to stay in his little crazy jail, so the square root of 3. So you would just write 4i square roots of 3. Okay? For today, you're not going to have to do much simplifying. The thing you need to know for today, think about this. If you square this, an I squared becomes a what? What happens when we square a square root? They just undo each other. So we actually end up with -1. This is super important that you know that, okay? I means the square root of -1, but I squared is -1. I squared is negative 1. All right. Whoa, didn't mean to write that. So we're going to go through what you do with these crazy problems. Let me try to make that bigger. Okay, just kidding. I can't. You have it on your paper, though, so you can see it? I'm sorry. We treat it like a variable here. These parentheses are just showing that this is one complex number and this is one complex number. But in the end, or I'll rewrite it without the parentheses, then when it's a little bigger. We treat it like a variable. Combine like terms and we get negative 6 and 8 is 2, 5i and 8i is 13i. We're done. Sweet. Can you get that one right? Easy peasy. Okay. The same with this one, but be careful. You got to distribute the negative. So it would be 8 plus 5i, and then when you distribute that negative, you would get minus 7 plus 3i. Is everybody good that there was a negative 1 out there and I distributed it? So then if I combine like terms, I have 8 and a negative 7, which would be 1, and a 5i and a 3i, which would be 8i. Now, if you wrote 8i plus 1, I would not count it wrong, but the proper form is the real part and then the imaginary part. It's called A plus BI form, and the directions will often say write in A plus BI form. Oh, I think I'm not supposed to be doing the evens. I'm supposed to just be doing the odds because your homework is to finish this worksheet. Well, that's okay. All right. So I'm going to leave you both of 3 and 4 then. Is that okay? One's adding and one's subtracting. So that'll take care of the fact that I did. Now I'll go to 5 and just do the odds. And I'm even going to cross something off, I think. All right. Number 5 is not an adding or subtracting. It is a multiplication. Okay? So we need to do double distributing or FOIL. We're going to multiply the let me write it out bigger, so I can see it at least. Negative 1 times 6 is a negative 6. Then negative 1 times 3i is a negative 3i. Is everybody okay with what I'm doing here? Just distributing to the parenthesis. So 5i times 6 is a plus 30i. And 5i times 3i, be careful, what would that be? It's going to be a plus 15i squared. Okay, so we have a negative 6. I can combine these two i's and get 27i. Back here, I need you to understand that this is 15 times I squared is negative 1, remember? So 15 times negative 1 will make that into a negative 15. And now it can be combined with this negative 6. And I get negative 21 plus 27i. So it's just foiling and treating everything like a variable until that very last step, and I squared gets replaced with a negative 1. All right, you cannot shortcut this. You have to do the FOIL. Can you guys try number 7 on your own? Negative 1 times negative 1, negative 1 times 4i, 4i times negative 1, 4i times 4i. Yes. Yes, that's a great question. Yes. Just like a variable, if you just see an I, there is a 1. It's a 1i. Great question, Bella. Negative 1 times negative 1 would be 1. Negative 1 times 4i would be a negative 4i. This would be another negative 4i. What do we get the back? Okay, and I squared is -1, so this becomes a -16. Can I skip writing out why that is, or do you need me to write that out? I squared is -1, so 16 times -1, I can write it up here, becomes -16. I just didn't want to have to rewrite everything. So then I had a 1, and back here a -16, and -4i minus 4i more is -8i. Did someone get that? Anybody lost, got something different, and they need to help me, let me help figure out where you went wrong? Okay. Now we get to the conjugate business, guys. Let me put a slide in here and let me talk about this. When you have, we'll say this means 2 minus the square root of -1, right? The denominator. Remember that stupid mathematician who keeps making up rules we don't like? Well, one of them is you can't have a square root in the denominator. Does that sound familiar? Okay. To get rid of that, when you have a sum or difference, in other words, got a plus or minus in the middle here, we use what is called the conjugate of the denominator, okay? The conjugate of a plus bi is simply a minus bi. You change the sign on b only. So the conjugate for my example, remember we want the conjugate of the denominator, which is this guy down here. Anybody know what the conjugate of 2 minus I might be? 2 plus I, good job. Now, what we have to do with that conjugate is multiply it top and bottom. And you don't have to write this example down. If you want to just watch, then we'll do the next one together. Does that sound okay? So what you would do is multiply that conjugate to the top and bottom. Now, this becomes a big exercise in FOIL because I have to do 3 times 2 is 6. 3 times I is 3i. I times 2 is 2i. I times I back here is an I squared. The denominator becomes 2 times 2 is 4 plus 2i. This is a negative I times 2, which would be a negative 2i. And a negative I times I squared, be careful, that's the one that messes people up, is a negative I squared. Now, what will always happen if you did this correctly is the denominator, those middle terms will cancel out. Do you see that? So we end up with a 4 minus I squared, which is a 4 minus -1, which will become 5. The denominator is now just 5. The top had 5i here, if we combine those like terms. But back here it had a plus I squared, which would be a plus -1. So 6 plus -1 would be 5. Wow, that doesn't happen very often. Okay, when we divide this and split it, divide each part by 5, we end up with a 1 plus 1i. Most of them aren't going to simplify that nicely, okay? I made up numbers and somehow I did a miracle. All right, let's try, let me see. I felt like there was one back here. Let's try number 9, okay? What is the conjugate of the denominator? Make sure you understand that conjugate of 5 plus 2i would be 5 minus 2i. Everybody good? And we're really just making it a form of 1 by making it 5 minus 2i in the denominator and 5 minus 2i in the numerator. Does everybody see what I'm doing there? By writing it that way, it's just 1, so I'm not changing the number. All right. This is a nice one because on the top we only have to distribute once. 10i times 5 would be 50i. 10i times negative 2i would be negative 20i squared. In the denominator, 5 times 5 would be 25. 5 times negative 2i would be negative 10i. Positive 2i times 5 would be positive 10i. And positive 2i times negative 2i would be negative 4i squared. Okay, on the top, what is a negative 20 times a negative 1? Yeah, this is going to become a positive 20 when we multiply them. Now, I'm making that confusing. Sorry, let me just rewrite it. So we end up with a 50i and a negative 20 times negative 1, which would become a 20 and a 50i. Now, I switched the order because eventually we want that a plus bi form. So I put the 20 out front. Okay, what happens in the denominator? Yes, yes, yes. That always has to happen if we did it right in the denominator when we're using the conjugate. And then we end up with a 25 minus 4 times negative 1, which would become plus 4. Everybody good? So 25 plus 4 is 29. And I will take this answer. If I assign a delta math on this, I think you have to write 20 over 29 plus 50 over 29i because they want the a plus the bi separated. But I'll take this, I don't care. Just so you're clear, that's the same thing. Whew! Can you try 11? What's the conjugate going to be? Yes. Okay, negative 5 minus 6i on the top. It's multiplied by a 3 plus 5i, because that's the conjugate of the bottom. Okay, start foiling. You're welcome to use your calculator, guys, to multiply or add or any of those if the integers are messing with you. Adriella, can you see from back there in that corner okay? All right. How many i's did you wind up with in the numerator, the top? Negative 43? Did someone else get that? A negative 25 and a negative 18. Okay. Now, negative 30 times negative 1 is going to become plus 30. I usually just do that and write it over the top there. And then I have a 30 and a negative 15 for my real numbers, which would add up to a positive 15. The denominator of these should make 0. And negative 25 times negative 1 should make that a positive 25. And 9 and 25 is 34. Yes, no. Anybody confused, got something different, needs me to run over, which I don't run very fast, but and try to see, look at your work and see where you missed something? Lots of room to make a mistake on these, right? You got to really be careful. Check your work. Okay. I'm actually going to ask you to just cross off 13 and 14. There's a shortcut to those, but I took it off the quiz, so I'm just going to skip those. That brings us to some crazy business. Okay, I did put one of these on the quiz, and you can't read this. I can't read this. Okay, we're not going to worry about this. I will go through this because some of you need this, will use this method, but okay. I'm going to talk about it this way. I can only remember two things because I have a very small brain, okay? I is the square root of -1, and I squared is -1. Can you remember those two things? Okay. If you can only remember those two things, you can still do some crazy exponent stuff if you also can remember these rules. Do you remember what happens when you have an x squared times an x to the third? How many x's do you have? Everybody good? Okay, and if I had an x squared to the third, do you remember what happens there? X to the 6th, okay? And I think those are the only ones we're going to need is multiplying, adding. Okay, then I need you to review this idea. A -1 to an even power would become positive, right? And a -1 to an odd power, like 15, every two of them would become a +1. So when you multiplied by that last -1 that was odd, you'd end up with a -1. Everybody okay? All right. We're going to use all those ideas to figure out this. This simply says, is this just say I to the 4th? Okay. If you divide that by 2, does everybody understand that that's the same I squared squared? Okay, we're always going to try to divide by 2. If it's an odd number, we're going to pull one out. We're going to poke out an I. Okay. So what is I squared? Remember, you told me you could remember those two things. I squared is -1. So when you square a -1, you get +1. So I to the 4th is +1. We can do some extra practice on these in a minute here, but let's look at 17. What? 122. Okay. Does 2 go into that evenly? It does. So we're in luck. We're going to do an I squared times, what would that be? 61? We're in luck because we know what I squared is. It's what? -1. And a -1 to a positive, an odd power, I mean, it would be a -1. Does everyone get why that is? -1 times -1 is +1. You're only ever going to get 1 when you're multiplying ones, right? But the first 60 would be positive, and the last one would make it negative again. Okay. Now we need to do some that are odd. Okay, we've got 19 is an odd number. We poke out an I. So we make this 1I times I to the 76th. We just took one of them out. Does everybody agree that that would be I to the 77? Okay. Now we're going to divide this by 2. And I squared, let's see, 2 goes in there. I want to say 38. Is that right? Anybody checking me out? Okay. And an I squared, you're memorized, is -1. So what is -1 to the even power? Just 1. So I have I times 1, which is just 1I. Is there more or no? Should I make up a couple? Let's do another odd one. I to the 215. The first step you would do would be to take 1 out. So you'd have an I times an I to the 214. Then what's the next step? Divide by 2. So we'd have an I squared times, oh Lord, 107? Okay. Now we still have this I that we poked out front. But what is a negative 1 to the 107? It's an odd power of I of negative 1, so it becomes negative. So we have a negative 1 times an I. Be careful, I just moved it to the back because we're multiplying. So we end up with a negative I or a negative 1I. I don't care how you write that. There are only 4 possible answers when you have a power of I. Let me show you. I is I squared is negative 1. I to the third is I squared times another I, which would be a negative 1I. And I to the fourth is I squared squared, which would become a positive 1. It's always going to be one of those 4 answers. There's another way to do those where you divide the exponent by 4 and whatever the remainder is tells you which one of these 4 answers it is. But to me, that's like magic. I hope the way I taught it makes a little bit of sense using those exponent rules. I like to think it's a good time to review those exponents. Bella. Say that again. Yes, you could just write negative I. Yep, I just was slacking. Yep, perfect question. All right, the assignment on this is simply, I don't have anything on here, do I? Okay, the assignment is just to finish this worksheet, except the one I had you cross out. And the answers are on the back, okay? Now, how much time do we have left? 6 or 7 minutes? Okay, I know you're probably not going to finish this right. Oh, sorry. Finish this right now, but can you, if you go on your, you know what? Yeah, I really would like to do this today. No, I really would like to not. Okay, I'm going to save it. I feel like you guys need some less stressful day today. How's that? Anybody need help on something? We have a quizzes. I want to do a little quizzes. It's just a little factoring practice thing so that I can see where everybody's at with factoring. But maybe we'll do it like Monday or something. I don't think we're going to have time tomorrow, but I want to get in some electronic activities or some using the technology to help do some things, but I'm not real. I'd rather today let you relax. Anybody have questions? Remember, if there's something you didn't go do well on the quiz, I have some extra practice up here. Can I help anybody? Like if you need practice on 0.1, 0.2, 0.3, 0.4, I have extra practice. It has worked out answers on the back. Your worksheet does not have worked out answers on the back. Worksheet, what was this, 9? I didn't stop the recording.